Hello, I am Agi again from FakeUp, and this is ArborSonic Academy, fourth episode dedicated to the time data tab. So, here we suppose that you have already fulfilled the three data on the first tab, you have a sensor geometry, and you are just ready to start the measurement. So, here it is. So you can come here only when the tomogram itself is on the tree. So the sensors, the needles, the nails are hit into the tree, and all the cables, amplifier boxes, and the battery box is just ready for the measurement. Okay, so please keep this in mind. You will see that there are many little things and many settings which can modify something. So first, I will go through what you can see right here. Then I will show you some application settings from the advanced settings. And at the end, I will close with showing you the settings related to the Ludwig sensors. So first, I will show you the most simple case when you have just a layer which you want to measure. I will show you some errors, mistakes you can make, and then I will show you the rest of it. But if you watch the whole video, you will know everything what is useful here on the time data tab. So let's get started. First of all, of course, you have to turn on the battery box, the gray box, which is recommended to keep turned off when you don't measure to save battery, but of course you have to turn it on right now. If you measure with the cable connection, it's very easy, very simple. The program can find the COM port, but if you measure via Bluetooth and this is your first time, you have to connect the device to your program. So you can come here for making the connections. If you connect with cable, you just have to push this button and it will work. But if you are connecting with Bluetooth, you can get some help here inside the program. So it can help you detecting a Bluetooth port, pair a new Bluetooth device, which pops up the Windows Bluetooth device pairing window. Here you can come like this at the new Bluetooth device, a Bluetooth device, and here you would see the ArborSonic if it was turned on. And you can also check the Bluetooth port settings. So this is the list of the COM ports which are used by the computer right now, and you can find out where is an ArborSonic and where are your other devices. So it's quite helpful. If you need to refresh this list, you can just come here and it will look for all the COM ports which are used by the computer right now. It takes a little time to refresh the list as the program has to check all the COM ports. When we are finished, we can choose which we would like to use. And if there is a connection, it will turn to green. Right now, we can start the measurement itself. So you can grab the metal hammer and hit the sensors. Please remember to hit in the nails direction at the head of the sensor. Don't hit anything else. Please don't hit the cables or the side, and try to have loose wrist and try to hit very similar. So keep your hit the same as much as you can. I will show you a simulation right now. But before I start, I would like to say something about these numbers here, because this is the count of good rows, good hits on each sensor. So the program can detect if a hit was very bad. So it cannot find all the bad or mistaken rows. So you can even hit maybe the side of the sensor and still get a row which is accepted by the program, but the program already looking for mistakes and errors in the time data. So if there is a bad row, it will not count, but if it seems like a good, nice one, it will count. So there will be a number increasing, so it will turn to 1, 2, 3. And well, it is a setting, I will show you later, where you can modify this number. So you can decide if you want only one measurement on each line. It is absolutely not recommended. It is recommended to hit at least 5 on each sensor, but you can modify it because sometimes, well, you lose data and you cannot go back to the tree, and still you can make a tomogram. Let's start the simulation. So here are the data arriving. And you can see as these numbers are going up and they are red until you have reached the number of the minimal good row count. So our data had arrived. On each sensor we have enough hits. And what I wanted to tell you is that this is a simulation. So now this device worked with 7.5 volts in the battery, but hey, this is bad. The battery box should be well charged. It really needs a well charged battery, so it must be over 8.0. The program will show you the current voltage of the battery, and if it goes below 8.0, please have another battery or charge your battery. And very sadly, we have faced a problem that even if you buy a battery from a shopping center, it can be on the shelves for so long it had already lost a part of its charge, and it's just not enough for the tomograph to make it go to have a nice measurement. So this can disturb your measurement, so please never do like this, okay? So just I wanted to show you this icon. It's red, so it's alarming. Let's see what else can happen. So in this case, we have all the nice data, and well, you can even see that the program itself can find which sensor was hit, but it's quite easy because you are just looking for the zeros. If there is a bad hit, I will show you, there is a noise, a sound of a bad hit if it's recognized by the program. So this is when you have bad rows. And then we have some more nice data. What can you do with the bad rows? You can remove them, delete them manually, or you can just let the program do it for you. Well, if there is a data, a measurement which you don't want to keep, you can just select one row which is bad for some reason, and you can delete or remove that one as well. The program will ask you if you really want to delete it. But if you want to repeat the measurement on your layer, you can just remove all the rows. Please be careful when you do a measurement and you have several layers, which you can see here, and switch between them, because if you measure a layer, and I will show you it in another file here. So there is this layer which was measured, and this looks like this with some problem in this area. And then we move to a second layer, which is just, well, it is quite nice. But what happened when we forget to switch in the time data. So the first layer was measured, and then the time data from the second layer was sent to the first layer's data. So this is how it looks like. It's absolutely mixed up because if you check the real data, this is that, and we have a problem here. But if you mix the data together of two layers, you will get an absolute different tomogram. So please never do that. So when you measure one layer, please keep in mind that you are measuring that layer and not any other. So please send the time data into that layer's data. I know it's a stupid mistake, but really it leads to very bad tomograms. So never do anything like that. So let's return here because we have so many data, more data here. Well, just before we go on, of course, you can start the measuring with the start and you can stop it with the stop, and this is used for the configuration as I have already shown. We will return there later. But what we can see here on the downside or in the right side, because we can switch the scan, how it looks like with this icon here next to the layers. But well, I'm used to this kind of set, so I will show you here what else is there. So we see the time data. It's the average time with the standard deviation. This is the default set, what you can check here. These deviations are quite low, so it's just 1%. Usually the program turns it into red, maybe this block, if the deviation is over 5%, but it's again a setting. So you can go it down to 3%. In this case, this would be red as well. So it's just a sign that maybe you should try to measure more on that sensor to hit several few times, or check the data because there could be maybe a wrong hit which wasn't removed, it wasn't found by the program itself, so you can remove that time data manually. You can see the standard deviation in absolute values as well, in microseconds. So here you can see these values. What can you see in the right? It's called the symmetric difference. This is a value showing you that how big is the difference when you measure maybe from the first sensor to the seventh and from the seventh back to the first. So we measure the time in both directions, and this shows you what is the difference. And this refers to sensors. So this shows up when you measure maybe from the first sensors to all the others, and from the others to the first sensor. This is usually a very low number if your tree is healthy. So it used to be maybe 2 or 3 or 1 or even 0. And it goes up when you have a decayed or problematic tree, and it can be as high as 100. So it's not a problem if it's high, if your tree is decayed, but it can indicate a problem if you measured on a healthy tree and it's still very high value, I mean over 20 or over 100, it may indicate problem with the sensor. We can check the regularized time, sorry for my English, as well, which means that they made an average of the time data. If you look close, you will see it's not only an average, but also It's made unified because of the wound materials in homogeneity in different directions. So this will be used for tomography. The maths and the science, the wood science, the material science behind it was measured by researchers and scientists long time ago. So it works right now. The time correction refers to that the sound travels in the wood material itself, but it also travels in the metal parts. And of course, we have to reduce the real travel time with this. So it will be a minus from the data. This is interesting when you switch between the normal sensors, which are 6 centimeters long, to the long nail sensors, which are 12 centimeters long, because in that case you have double the size of a metallic part, so this correction will go up, so you have to switch the settings. But normally it's just something calculated by the program, and you can leave it and go on to the tomograms. We just finished with the first part. Let's see which settings affect this tab. Okay, let's start it here with the reader configuration. Let's see what are sensor redirections. Okay, maybe you are on a field and you lost a sensor, or one of your amplifier boxes is not working well. What can you do in this case? Maybe your box 7 and 8 is not working, amplifier box. You can add here zeros. That means that there is no information from them, so the program will not wait for them. But the program still waiting for a sign from the 7th sensor, unless you are trying to measure with only 6 ones, which is absolutely not recommended, because there will be so huge gaps in the tomogram itself. So, I mean, there will be only a few lines in the tomogram itself, so the tomogram is not very nice in this case. So you still want to measure with 7th and 8th sensor. So you connect them to the next amplifier box, which is 9 and 10, but you have to tell it to the program. So you will say the data from the 9th amplifier box, or it's 9 and 10, will belong to the 7th measuring point, the 7th sensor. And the data from the 10th will go to the 9th measuring point or sensor. Okay. And well, you can switch the next ones as well. Maybe like this. So in this case, you still measure with 10 sensors, but one of your amplifier boxes is not working. This data will be here. So the program will highlight that, hey, you did a sensor redirection, take care of it, keep it in mind. So now you can go on and hit the sensors, and the measurement itself will be similar. Please remember that on the geometry tab, so you tell the program how many sensors you have. The time data tab just gets this information from the geometry. So the program itself will only know if you measure with 10 sensors if you tell it. So here I reduced it to 10 sensors. So now on the time data I have only 10 sensors. But in this case I have so many bad rows because data came from 12 sensors, not only 10. The sensor redirection Okay, let's see the case when it is extremely useful. So it is very useful if you have a problem, but it's also very useful if you have a tomograph with many sensors. I mean, maybe you have 24 sensors or even 32, and but maybe you don't need a tomogram so detailed, or your tree which you want to check is a smaller one, so you don't need all the 32 sensors, but you think about measuring two trees at the same time. So in this case you can switch, separate your one tomography into two tomographies with, for example, 16 channels. And in this case, you can start here with the 17 and 18, 19, and so on. You can imagine it that you can do this measurement. Okay, one more remark if you do something like this, that the system needs the first battery box. So the first amplifier box. So the amplifier box 1 and 2 is a little different from the others. And if there is no amplifier box 1 and 2 in the system, it will make it a little uncertain or unstable. So in this case, if you want to do something like this, please ask us and we will help you how to modify another amplifier box to be able to do a measurement like this. Okay, let's return to our other file. And well, I will just turn off the sensor redirections. Great, now everything is gone back to normal. What else can we do? So first of all, I will get back the data here. So let's check which settings affects this tab. They are here in application settings and on the advanced tab. First of all, here is this minimal good row count. I have already told you that, and I will show you a simulation of it, that maybe you was in a hurry and you didn't measure 5 times or not 3, just only 2 times on the last sensor. So I just removed these rows, and now it's no matrix, not enough data for tomogram. You will not see what's inside the tree. Well, this can be solved here if you reduce it into 2, and now the program can calculate with it. So it's possible, but it's recommended only in an emergency situation. So please keep the 3 as the default, but try to hit at least 5 times every sensor, okay? Let's see what's next. The minimal TO and the maximal TO are the time corrections here. So when you have the normal sensors with normal nails, it's 12, 20 and 35. You have to modify these numbers when you use the long sensors. Okay, it's in the manual. In any other times, don't do anything with that. Okay. The next one which affects this window is this relative time error threshold percent. And if I reduce this, it will color, so the relative, checking the relative values where the deviation, the standard deviation is higher than this value. I can go even more for 2, and now I have more red blocks. Well, 5% of error is acceptable in this case because it's a measurement. So, like in physics, for the most of the cases, it's just good as it is. So just keep the 5%. And here I can set back all the data to the default ones. Yes. Okay, and now I don't have enough measurement here, but I will solve it in a minute. Because now we have the last part of the video, we checked all the things here that we can go back to sensor geometry and turn on the Ludwig sensors. Of course, it was measured before, the positions, but now the time data tab is also changed. It's different because all the Ludwig sensors are added here, and you can see that they are waiting for a number of hits as well. And in this case, first you have to make a normal measurement as you used to measure. You have to hit the sensors themselves at least that many times, which is set in the minimal good row count. Then you can switch to Ludwig sensors, which I cannot do here because I don't have enough data, but I will have enough data in a minute. Okay, now I have enough data, so I can go to
L1
Ludwig. Video in the video is coming because yesterday I recorded this with being here, but now I will move to the other side. So here I am, and now I can show you these buttons over there. And in this case, we have all the data we needed, so we can go on to the Ludwig sensors.
L1
Hey, and the program tells me that I should measure on the first Ludwig sensor. When the auto advance is on, this is how it will go. So it will tell you to hit Ludwig 1, L1, and then L2 and L3. I will show you.
L2 L8
So the program always jumps to the next Ludwig sensor when you have enough hit on each of them. And what is enough? This is the value here at minimum good row count. So this function is only to speed up the measurement. You don't have to use it. You can uncheck it and you can tell the program which sensor you are, which Ludwig sensor you are measuring on, and you can have hits on that one. But you know, it just make it a little slow. So that's why we have this auto advance function. Here we are when we have all the data which we needed. And well, we are ready in one hand because now we can go on to tomography. But you can check very similar data you have seen before. So here are the time data with the standard deviation. This is only for the sensors right now, but you can check the Ludwig sensors data as well. So the matrix is really huge now. But we still have a few functions here. So this part is really for measuring just one sensor. Maybe you want to repeat it. I mean, one Ludwig sensor when you want to repeat it manually. And these buttons are for switching the condition if a hit is coming from a Ludwig sensor or not. So it will not delete the data itself. It will just change the condition, the group where it belongs to. So maybe I think that, it's a hit on not a Ludwig sensor, but a normal sensor, so I can remove the condition that this is a Ludwig sensor. So here you see the L12 just disappeared. And the program tries to find which sensor was hit, but it see that it is a bad hit, so it will not count as a normal good hit, but of course it's not that. So this is for this red X, and the other dispenser puts a line into the group of one Ludwig sensor hit. So maybe you think that it was a mistaken hit, it wasn't on the 12th, but it was on the 11th. So you can choose the 11th Ludwig sensor and give that condition to this line. And well, the program thinks it looks good enough to be an 11th sensor, which is really not, or not an 11th Ludwig sensor, but you can do it. Or you can, the best is to give it back its real condition, the Ludwig 12th. And now everything is working nice and we have enough data. So this is how you can use these buttons here. Okay, I will go back to the other corner to finish the video. I think it was all from time data. I think it was a little long, but I hope it was useful and I hope you could understand all. If you didn't, but you can write the question to our email address or here to the video comments, and we will check them and try to answer. And well, if you like this video, you can check the previous ones. We have a video on how to measure with Ludwig sensors if you are interested in one. And this ArborSonic Academy is a series and it's going on. And well, I hope to see you in the next episode. Bye bye.